So the next section is getting the most out of the device. And now we are going to the area where we bring together your QML UI and C++ application. Now, why do we want to do that? Can't we just write our whole application in QML? There's UIs, there's JavaScript. We could just implement everything on QML. Well, the idea with Qt Quick is that you implement your application and the business logic in C++, where it's fast, where you can access things like models in a more meaningful way, like work with Q abstract models, for example. And then you can bring those objects into QML and implement a visual representation for the data and the whole UI of your application in QML. And the UI layer is something that's sufficiently separated from your native code application that it can be changed. You can change your QML UI layer based on which platform your application is running on, or which platform you are deploying it to, or packaging. So obviously, this is something that's really quite important. And in this section, we will cover that. Other topics for this section are NFC, but I think we'll leave that mostly for the demos, just a quick overview of what's available, what elements there are for accessing NFC, and how to handle the data. And then, of course, there's Qt Mobility APIs, sensors, location, things like that. These are also things that will be demonstrated in the last section. Okay, let's have an overview of Qt Mobility APIs first. So, as we mentioned earlier, Qt Mobility APIs provide you access to different features that are available in modern mobile devices, like, for example, sensors, things like that. Let's see what's available. There's, messaging, contacts, system information, access to Versit, digital business cards. There's sensors, there's multimedia, camera, things like that. Location API, document gallery, feedback, for accessing the vibrating device on your mobile phone. And the dark ones are in Qt Mobility 1.0 or 1.02. So these dark ones are available for the old Symbian devices. They were supported in Qt 4.6 series. The light, middle blue items are in Qt 1.1. And they are available, for example, in Symbian 3 devices, MeeGo. And the rest are for 1.2, and I think at the moment they are available in Bell, probably. And so QML bindings are there for some of these elements, so we have access to them from our simple QML UI. And we'll see how to make that happen. There's a little bit more described list of what's available, but let's not go there. So as mentioned before, we have access to a number of elements from QML. Location API is one example. There's the map API. And then we have things like sensors and others. There might be certain capabilities on Symbian that we need to define for our application to be able to use these technologies, like, for example, location data. And to define these capabilities, we can use this target capability in the project file.
You'll need a certificate for that, will you?
The question was, do we need a certificate for those? Those APIs are, or capabilities are available in self-signed packages.
Also location?
Sorry?
Location?
A location is there, so you can use it. Okay. So we need to define some of these capabilities to be able to access certain features of the Symbian phone. And in case of, for example, network access, we need to define the capability so that our application is capable of accessing network. And this is true for many other services as well. But you can see the documentation for what capabilities are needed, and usually it's quite straightforward. So there's a small chart of the capabilities, but let's not go there. In the beginning of this training track, we had Jukka who told us a little bit about publishing your applications in Office Store. And in the final section of today's training, another person will come in and explain the whole process of packaging and signing your application and publishing it in Office Store. And that will show you how to get your applications available. So we don't go very deeply into those issues in this training, in this part of the training, but just to underline that it's something that can be done quite easily. So that's how the security works in Symbian. How about Harmatsan or Migo? On N9, you have some resources are also privileged. So you need to have access to a number of resources. And in that case, you have to define a manifest file. However, in general, the SDK takes care of this automatically. So depending on what features you are using, the SDK detects that, and then it will implement the IG's manifest file so that your application will be able to automatically request all the access to all the protected APIs. But in case the SDK fails to detect that your application needs something, you may need to modify the manifest manually. So this is an example of what the manifest file looks like. And much of what you need to do, you can do straight from the SDK, from the Qt Creator projects page, and it's relatively straightforward. But usually, there should not be any problems in this area. Just some that you need to know. When you are writing applications for N9, you need to be aware that there's also this security framework that might limit what you can do or what your application can do unless it requests the correct access to the APIs. So let's go to examples of these different APIs. The sensors API, for example, provides you access to different sensors, like rotation sensor, for example. So it lets you know, lets your application know if your device is being tilted in different ways and enables you to react to that. Using these APIs is quite straightforward in QML because, once again, you are using the declarative power of the QML language itself. For example, to access rotation sensor, you need to import Qt mobility.sensors 1.1. So you are taking the sensors module into use. And this line provides our QML UI with the elements that it needs to access sensors API. And then we are using rotation sensor QML element. By instantiating this element here, we are able to tap into onReadingChanged signal handler. This handler is called every time the reading of the sensor is changing. And then it's just something that you need to get from the documentation, but you're told there that what you get is reading value. And this reading is a structured property, so you will get reading.x, y, and z that you can then print out, for example, or you can do whatever you want with them. You can make your application react to these values. They are integer values from 0 to the angle of the rotation. Go ahead. Can we have the microphone, please?
Hi. What's about the GPS sensor? Or
Location.
yes, you mentioned the compass and accelerometer and gyroscope and something like that, but no GPS or something. No GPS sensor.
We have the location API. That's actually our next example.
Oh, okay.
And that provides access to location. So it's not in the sensors API itself, but has a different API.
Okay, it covers both GPS and the cell ID.
There are some limitations. So what you get is coordinates, and
Okay.
you might not have much control on how to get those coordinates.
Okay.
There are a number of limitations in location API. For example, the map element at the moment. When you are using map element, which we will be showing next, the thing is, it can show you a map. So you are using Nokia device, right? Nokia device has great features for location, great maps, things like that. There's just one problem at the moment with the map plugin used by QML. The thing is that it loads the maps from the internet. And to my understanding, at the moment, it's unable to use locally stored versions of the map data. And if it hasn't been fixed already, then I hope that it will be fixed quite soon. But that's one of the limitations. But on the other hand, it's really straightforward to use. So you have map. What you do is that you instantiate the map element. Go ahead. The mic, please.
Actually, in the documentation for the map element, I see that there is an offline mode. Do you mean that it does not work, or is it new?
When has it been added? Can you see?
I don't know. I have the latest Qt creator.
Okay. Might be something that has changed, but my understanding has been that it was not there. But I haven't been using it for a couple of months. Maybe it's changed during that time.
Okay.
Or maybe it doesn't work, I'm not sure. But if you can check it, then please share that information with us. So if I'm wrong, then I will stand corrected here in front of everyone. Okay, well, let's go to the example of using the map element from Qt Mobility. So once again, we import Qt Mobility location module. That gives us the map, for example. And in this case, we have a simple item that acts as the root element. Then we have the map, and we make the size of the map the same as our root element so that we can show it as a large element on the screen. Now, in this case, we are not using the anchors, like for example, anchors.fill or individual left, right, top, bottom anchors. There are reasons for this approach. For example, if we would want to animate this UI, slide it away from the view or something like that, in that kind of cases, we should not use anchors, but we should use another way of setting up our UI. And this works for that case. Anyway, we define which map plugin we are using. In this case, it's Nokia, and that's pretty much the one that we want to use, on Nokia platform. This provides us access to more Nokia maps data. And then we can see the maps. We tell our maps where we want it to center in, so that it will show the location of that area. And then we give it a map circle. We give the coordinates for that circle, and we give the radius for that circle, so that it will show, for example, your location in the map area. And as usual, you can use the circle for defining how specific the data is. I mean, do you have a question? Can we have the mic, please?
The coordinates are WGS84 based coordinates or whatever.
Sorry?
The coordinates in the location API are probably WGS84 GPS coordinates, and that if you have 7 digits like here, then you have to take care that the map has got the same coordinate system. Is that true here?
Frankly, I'm not sure about that, but I think the documentation probably knows it. It's not a problem that I bumped into. It just usually works. Okay, so now that we have our map visible on the screen, let's add some UI layer. And this is the way that you usually do when you implement your application. It's really easy to add new layers of UI in QML. So we have the map, and then we'll add some new elements for buttons. In this case, we assume that we have an element named as my button. That's basically a custom component. It would be better to just leave the button out and use Qt Quick components, but in this case, that was not used. So we'll just add a number of buttons for switching to different kinds of map modes and zooming in and out of the map. And these actions are nicely supported by the map itself. So there's map type, which we can set to map.streetmap or satellite map day. And then we can modify the zoom level, zooming in and out. It's better. Okay, do you hear my voice still? Good. Okay, so the first point on this slide might be outdated if the offline plugin works already. Then to get the position from GPS, for example, you can use position source QML elements, which is a non-visual element that provides these latitude and longitude properties. And yeah, that's how easy it is to implement something that uses map in a QML application. And we actually have an example of that if you have checked the source repository for the demo application already. Then we'll go to NFC, near field communication. This is once again relatively short introduction to the APIs that are available in that area. Okay, so NFC is a technology that's getting more frequently available in modern mobile phones, like for example C7, N9, things like that. It enables you to read and write NFC tags or communicate with other NFC devices in very short range, in wireless communication. Not very fast, but it's not required to be. This is also something that we have an example of in the demo app. So there's an example that you can use for writing and reading NFC tags. There's also another pretty nice example that's available on the internet, and a bit later in the next section I will show you a demonstration of that application. But right now I have to skip that. Okay, and what uses are there for this kind of technology? When you went to lunch, you probably saw these little stands in there, in the lunch line, where you saw the NFC, something very similar to this. And there was this text that told you that you can easily download the DevDays application on your mobile phone by touching this tag. So that's one possibility. You just use your mobile phone, enable the NFC, and then you touch the tag, and it'll give you the information that your phone needs to download an application. So NFC tags are also some that are available on QML. There's a census, an API in Qt Mobility for accessing NFC capability in your phone. But there's a couple of ways. First of all, you can interact with tags, as mentioned before, and other devices for peer-to-peer communication. There's an example of that as well in the demo. Then, of course, you can read and write individual tags. Now, there are direct elements for implementing QML over application. First of all, you need to import connectivity module, version 1.2. Then you have near field, which provides you the access to the actual NDEF messages that define the message format used by NFC. and a number of other elements as well. But we don't go into so many details at the moment. So on this slide you will see a simple classification of which elements you will need for accessing different functionality, which are required for generic use of NFC, so shared by different areas, which are required for accessing tags, and which for implementing peer-to-peer communication. But let's go to an example. So in this example, what we do is that we implement a simple or instantiate a simple near-field element. We can implement certain filters for limiting what information and how much information we want to receive. And then, once again, we have a signal handler. So this is also something that we can utilize in declarative manner. We implement a signal handler, and then we add a block of code for managing the situation when the signal is received. In this case, we are just adding the text from the tags to a list model. Okay, that was short introduction to a number of Qt mobility APIs. But what we are going to go to next is an important area. C++ and QML are separate parts of your application. And you want to be able to communicate with those, between those different parts. And next we are going to go over a number of different mechanisms that can be used for implementing that communication. First of all, something that we need to realize is that when we talk about QML, we talk about different elements like rectangles and images, items, things like that. They are something that live in the QML world, but they also have representation in C++. There's QDeclarative class in C++. It's part of QDeclarative module. And that class is something that you can use to access items on QML side of the fence. And this is possible because of the Qt meta-object system, which QML is largely built on. This also means that you can create your own QML elements. You can take the Qt declarative item class as a base class and extend it to create your own new QML element. And you can then add that new type into the QML context and use it in your QML code. That way you can implement elements that have custom visual style, for example, because you can use QPainter for painting on those devices, on those elements. Whatever you want to paint, you can do it. In more general way, this is an interesting little detail. QML is based on QGraphics view. All the QML elements, they live in the QGraphics machine. And that means that you can combine these two things. You can take your graphics view from QML, QML engine, for example, the Q declarative view. And you can access this graphics machine, and you can add graphics items from C++ side into that machine. They won't be QML items, but they will be visible in the same UI. This means that it's really easy to implement an application that has some heavy visual content that's not limited by QML and the mechanisms that work with QML. But it's still visible in the same UI. And then you can add, for example, a QML UI layer on top of that, that view. Let's say a game. Graphics view-based game is quite easy to implement using these mechanisms. Okay, so let's see a simple example of implementing a simple communication between QML and C++. So we have a module known as people in here. In that module, we have an element, person. Now, the module and the element are both something that are not part of official Qt. They are something that we want to define ourselves. So what we do is that we select a base class first. We have a number of choices in there. We can use QObject, which means that we would implement a non-visual item. We can take any QObject and we can just put it in the QML context, and it will be available in there, meaning that the QML object's slots are available as functions in QML, and its signals are available as signals in QML as well. And its properties, those properties that are defined using QProperty, are available as properties in QML side. So this means that we can take, we can implement a simple way of exporting QObjects to QML. Another thing is that we can define types, but that's something that we will show you next. So, in addition to QObject, we can also select a QDeclarative item as our parent object, parent class. And that is for visual items. If we want to implement something like a rectangle or image or something like that, something that has position, dimensions, and visual representation on the screen. And of course, there's the QAbstract item model that can be used for bringing models from C++ to QML. So you can implement just your view in QML. So this first case is a simple one, so let's just select QObject. What we do is that we write the class here. It's QObject-based class, plain and simple, nothing special in there. We have QProperties. Now we have to define these properties using QProperty and not the setProperty at runtime. And as you can see, there are read and write functions for the property, but there is a problem in this approach, so let's say this is not the correct way of doing it. And then in the main function, when we have actually defined our class, we can register that class to QML. And doing that, we use this template function, QML register type. We template it for our new class, and then we give the name for the module, we give the version number for the module, and we give a name for this particular element in QML. Okay, in the last slide, I told you that it was not the proper way of implementing QML, new QML types in C++. That's because we were lacking the notify signal. And notify is something that we need to make sure that property binding is working properly with our new elements. And to implement that, we need to just implement the notify signal that we emit whenever we change the value of this particular property. So what does it mean on QML side? In QML, we are using our person as an element, just the same as any other QML element. Now what we need to remember to do is to import our module, the people 1.0. Okay. Then we have the name and the shoe size, the properties that we defined in C++, and they are now available in QML. And we also have the property changed functions available in QML as well. So we can react to changes in those names. For example, we can try those changes using mouse area by changing the name of the person when the mouse area is clicked in this example. A question?
Name changed with a capital N in QML and with a lowercase in C++.
The question was, is it correct to have capital N on this slide, even though we had lowercase n on this side? Yes, this is correct. And this is actually something I'm sorry to say is not covered by these slides because we are putting a lot of information in a relatively tight schedule. But the mechanism for defining signals so that they are available in QML is something that has a naming convention. And the naming convention is that you need to have, well, when you have a signal for a property change notify, in QML, to access that signal, to receive it, you will need to implement signal handler property. And signal handler properties are always named so that they begin with on and then with the name of the signal, with the first letter capitalized. So name changed with lowercase n becomes on name changed with capital N. That's just the naming convention. And more specifically, notify signals for properties have changed, added. So notify signal for, I mean, in QML, if you have a property, it automatically implements a notify signal for the property. In C++, we had to implement it separately. But usually the notify is named such that there is name of the property with the first letter capitalized and then changed, added in the end and on prefixed. Okay, so where was I? Oh yeah. By this code, what we have is a custom type for QML, which is implemented completely in C++, then brought into the QML context, and we are able to use it in QML. So that's the basic case for QObject-based elements, non-visual. Let's see another example of a little bit more complicated object, in this case, visual item. How to introduce visual items from C++ to QML. So this is an example that we want to achieve. We want to be able to import charts module. We want that module to contain an element known as pie chart that basically just draws something like that. So elements with these properties. How to do it? Well, the basics are quite similar to the previous example. In previous case, we were extending QObject, but this time what we take as a starting point is QDeclarative and we extend from there. QDeclarative has virtual paint function that we are using in this case to implement the actual painting. Properties are defined in the same way as in the previous example. In addition, in the constructor for the pie chart, we need to disable flag QGraphics item has no contents, because our item has some contents. It's going to draw something for itself. That's basically an optimization in QML. Then we need to implement the actual paint function. In this case, our element is quite simple. It's relatively stupid. What it does is that it draws this little pie chart for us. So it's just the paint function being called, and then we use the painter to draw something in the area for that element. And once again, we need to register our type to make it available for QML, like this. Very similar to the last case where we registered our person. This time it's pie chart. Adding module charts, version 1.0, and element pie chart. So it's that easy. The previous case, 2 examples. They implemented new types that are available for that specific application. But we might want to implement something that's available for all the applications that are installed on a specific device. Meaning that we can install new modules system-wide. And to do that, we can use QML extension plugin. This means that we will be able to implement QML elements, custom-made elements, that are available for every QML engine that we create. And using this mechanism, we will be able to implement our components so that they are available for QML Viewer as well. QML Viewer was the tool that we can use to preview our QML UI without the actual C++ application. Okay. So one thing that we need to remember, I mentioned this earlier shortly, but when we implement the application, the reason why we want to implement C++ side of the application is usually that even though you can do many things in JavaScript in QML, it tends to get a little bit messy. The implementation will be convoluted and difficult to read and difficult to maintain. And more specifically, your implementation on the QML side is something that you will probably want to differentiate for different platforms. Like, for example, on Nokia platforms, Symbian or MeeGo. So for that reason, already it's a good idea to implement the common parts of your application in Qt, where it's fast. All the sort of back-end functionality, things like that. Then, of course, if you have some areas in QML that are shared between each UI implementation for different platforms, those can easily be separated into separate files and loaded from there. But the basic message is that when you are implementing applications with Qt Quick, pretty much always you want to have the C++ side of the application in there. Not just QML, but always C++ with QML UI. And use QML just for the UI and not try to do any too fancy tricks in the QML side. Okay, do you have any questions? Go ahead.
Actually, I have only one question, that is whether there will be similar devices with gyroscope or the rotation sensors available, because I guess that's only available on the N9, is that correct?
With gyroscope?
Yes.
I have no information what is going to come from Nokia.
Right.
Basically, what I know is that we have the devices that we have at the moment, and that's it.
And do you know if there's some similar device with gyroscope or rotation sensor?
I'm not aware of that.
Okay, thank you.
But rotation is basically the one that we have been using, because that's usually available.
All right.
Any other questions? Is there any topics in this section's area that you'd like to recap or go into with a little bit more detail? Sorry?
The URL for the slide, you wanted to give the URL for the document for your slides.
No, sorry, I didn't hear.
The URL for your slides and demo code.
UI? URL, yeah. So this one. Yeah, but it's in the next section.
Okay.
I mean, is there something that you want to go back to in this section and discuss in more detail? If not, then I suppose we can have a break and go to the demo next. I think we have enough time to go through the implementation with some detail.
I guess because coffee is served probably
what we can do, I mean, it takes some time to set up the things and make sure that we have the ability to switch screens properly. So I think we'll need a break for that. But what we can do is that we can demonstrate some parts of using the SDK. So there have been some questions about what platforms do you need for targeting different devices. Like, for example, what's required for Symbian, and what platform do you need? What dependencies do you need for example, MiGo development? So let's go into that in a little bit, little detail. So what I'm going to do is that I'm going to launch my Qt Creator. Okay, I think we can make it visible enough. The problem is that I'm having some problems with my eyesight at the moment. So I'll try to see the text. Okay. So this is Qt Creator, as mentioned before. It's something that most of you are probably familiar with already. And what we have here is the welcome screen of Qt Creator. It provides us access to news and things like that. But let's go and create a new project to see what we have available and what we need to do to target Nokia platforms. So first, we want to implement a Qt Quick application. So Qt Quick application project. We could select just a UI project if we want to implement UI separately or target just the QML viewer. But as said before, in usual case, when you are implementing an application for using Qt Quick, especially for Nokia platform, you want to select Qt Quick application and build a whole application using that. Okay, then what we need to do, we'll give a name for our new project. Let's name it test 1. And now we get to select the application type. Now this is something that's more or less specific for mobile apps, because we get to select Qt Quick components for Symbian or for Migo/Harmattan. And this already illustrates that we need to implement separate UIs for those platforms, because there are meaningful differences in how components behave on Symbian or Migo. So let's target Symbian. And then we get to select which platforms we want to use. In this case, we already selected Symbian, so there's only so many platforms that those components are meaningful on. So it's basically Symbian device, but we can take simulator as well. And this wizard takes care of some of the capability management for Symbian platform. So if we require network access, we can enable it here, and the capabilities will be set properly. And this is what we are going to do. So let's just go on and finish creating our new project. Okay, what we have here is the basic template or boilerplate code for Symbian Qt Components project. We have main.cpp, which basically just instantiates QML application viewer from this class, which actually inherits from QDeclarative view. And then we set our main QML file. Yeah, it shows almost completely for that view. And then we show the application. So this is what we need to do to make a QML UI visible. Then we have the QML UI itself. This is the main.qml. This is Symbian specific implementation of this view. It relies on Symbian components, so it imports com Nokia Symbian here. And it's using window element as its root element. Based on this default implementation, what we get is status bar, initial page tag, toolbar, and it even loads our main page here. So the main.qml implements the window, management for pages, but not the actual initial view. That comes from main page.qml, which inherits from the page element in Qt components. And in this case, what we are doing is that we just show text. Hello world. Okay. It's really simple application. So if you want to see it running, what do we need to do? I'm connecting a mobile phone, N8 in this case, with a USB cable to this laptop. No, we don't actually have any content in that area yet. It takes a little bit of time. Can we go back to the laptop, please? Okay, thanks. It's not connected. No, it's not connected yet. No, just to the computer. Okay. So, first, to build this application, we can just hit Control B or select build from this pop-up menu or the toolbar or wherever we want to. And now that we see that the compiler was building the application, we should be able to see some output in here. And first of all, the target that we used was simulator. So let's see what happens when I launch the application. I pressed Control R or this and this is interesting little problem. The laptop with its encrypted hard drive is a little bit slow. It takes some time to launch the actual application. And this time it worked. Quite often what happens is that the simulator takes such a long time to start up that the creator gives up and decides that, hey, the simulator isn't answering. So when you launch the simulator, what you probably want to do is that you leave it running for the time that you are using it. Because you can easily just exit your application, the simulator is still running, then you rerun your application and there it is again. And much faster this time because you don't have to restart your simulator. Okay, so let's have a view at what different targets we have available. This is the simulator that we already used. But we are probably more interested in the actual device. So I selected the Symbian device and build configuration to see what API versions are available to me. And in this case, these are the Symbian versions that I have installed. And for this demo, I have selected Symbian Bell, which is the latest release of the Symbian 3 platform. And let's go with the release, so we'll get a nice and deployable application. Almost ready for the store. So, I have selected Symbian device. We can see here that we are using Symbian device. I could switch between configurations in here. And now I have the phone attached to the laptop. And what I'm going to do is that I'll also attach the phone to the projector using HDMI cable. And then I'm going to execute the application. Blind, but should work. And it takes some time while it's compiling. Then deploying, hopefully. And now the application is coming to the phone, and now it's running on the phone. So with Qt SDK, it's really simple to test your applications on your real phone. Let's see what we need to take into account on the package management front. Thanks. I will go to the Start menu of this Windows installation and find Qt SDK, and from there I will launch Maintain Qt SDK application. I will do this as administrator because the installation tends to break down if I run it as the user. The problem is partially that we have relatively tight security policies in these laptops, and they do cause a number of problems in different contexts, this being one of them. Okay, so one question that was asked was, which platforms do you need to install for the Qt, and what do you need to do to be able to target different platforms like Harmattan, for example? So let's go to the package manager of the SDK maintenance tool. In here, we can see a very, very small window. Okay. So, the SDK maintenance tool, it is divided into different categories, like development tools, for example. And we have number of APIs, and then we have experimental. And the Harmattan API is available in the experimental category. I don't think it's installed by default, so you need to either to do a custom install, or you need to launch the package manager and select these components separately. And that way you will get the Harmattan libraries, APIs, etc., to be able to build for that target on your computer. This is available on Windows and Linux as well. I suppose it's available on Mac, hopefully. And then there's also Qt components. And these come with desktop target as well for that specific platform, so you can try it out in the simulator, for example. For Symbian, when we go to the demo implementation, you will see that some of the APIs that we are using are only available in Qt SDK or in Qt 4.7.4. And for that, you need to install Symbian Bell on a Symbian device to make it work. And it's a separate install. once again, you may need to do a custom install or access package manager later to make this available. And there is one slight little problem that some people have bumped into with Symbian Bell. If you have a device like, let's say, Nokia C7 or N8 or something like that, which is provided with Anna, Symbian Anna upgrade at the moment, but no official release of Bell. It doesn't have Qt 474 libraries installed by default. So you will need to install those manually. And to do that, at least some people have reported that they can just go to the Start menu. At the moment, you are not able to see that, but okay. So you can go to Start menu, All Programs, Qt SDK, and there's supposed to be an option here for installing the Qt libraries in your mobile phone. At least for me, it doesn't show up in this menu. So that's a bit of a problem. What to do? Well, if I want those libraries in the phone, I need to go and do it the old-fashioned way. So let's go to Qt SDK directory, find Symbian. This is the location where I have installed my Qt SDK. SIS Symbian 3 Qt, for example, and version 474. There you will find the installation package for this version of Qt. And now you need to install it on your phone manually. So let's just okay. I'll need to. There it is. Okay, that did not work. But this should at least work. So I'll drag the installation package on the device symbol for this N8 mobile phone. Then it asks if I really want to install this application. Well, in reality, I have it installed already, but I suppose it doesn't harm anyone if I just go and install it again. And now it's just that, hey, you want to install this application. This is just the basic, normal application installation process. Nothing special about this. Just the same thing that you do with any other application that you install manually from an SIS package. So, well, it's not necessary for you to see what happens on the screen, but there's just the question if I really want to install it, security warning, yes. Select memory device, and then it starts installing. Okay, so that's the basic package management to get the libraries that we want on the computer and on the device. In addition to the Qt itself, there's QML viewer that we can install as well. So the QML viewer, if you put it in your device, you are able to use the device itself to easily test plain QML UIs without a C++ application. But bear in mind that it's not supposed as a replacement for an actual application as a host for QML UI. Then we have Qt WebKit, Qt WebKit module, which might be something that you will want to install, and a number of other APIs, like, for example, Qt Mobility 1.2 is available here, so you can install it on your Anna device, for example, to get the libraries that would come with Bell. There's Qt Components, obviously for Symbian, and you can go and install these on the device. And then, of course, there's the debug agent that you will need on the device. Can be installed manually here or in the menu here. So, any questions on these topics? Do you have?
The same guy I was asking.
Can you wait for the microphone, please? So we get the voice on record as well.
The Symbian up1 version installed in the SDK doesn't seem to have the Qt 4.7.4 libraries, does it?
Which version?
I mean, the Symbian up1, you showed the up3.
Yeah, for Symbian, you mean Symbian 1
yes,
here? Yeah. I don't think they have 4.7.4 available.
It stops at version 3,
Yeah.
4.7.3,
Yeah.
yes.
And for some devices, it's even older. The newer versions might not be supported. But yeah, that's the situation. All the devices are not going hand in hand in this situation. Basically, my understanding is that when we go to Bell, after that, the idea is that we will start receiving new Qt upgrades on Symbian platform with new OS releases, and not as separate updates. But especially for the older target devices, there is the smart installer that you can use. Yeah, you can quite easily configure your application so that now I need to figure out a way to switch displays again. Okay, I want to make this one my main display. This should bring us back to our previous Qt creator instance. Yeah, if you have a Symbian project, funny, I can't see it. There should be a selection for Smart Installer here somewhere. Or might have been in the wizard when you create the application. Well, anyway, there's a way to let your let the creator know that you want your application to be packaged so that it will use Symbian Smart Installer, so that if the device where it's going to be installed does not have the up-to-date versions of Qt libraries, the Smart Installer is able to go and retrieve those and install them from the network. And that takes a little bit of the pain away from managing all these different dependencies, version dependencies. But then again, if you are targeting some APIs that are not available in all devices, then there's not much that you can do. Okay, so I think we can go to break at this point. And when we come back, then we will start with the demonstration. I'll just set things up during the break, so maybe 20 minutes.
Yeah.